All right, so monomials. Let's work with monomials. I know these are terms that you've seen before. A monomial is basically a number, a variable, an expression that is the product of one or more variables, numbers, expressions, right? So there are no, they're just products, okay? So how do you know when a monomial is simplified? In order to have a simplified monomial, there are no powers of powers, right? For example, you don't have x squared times x to the 4. You don't have x squared to the 4. Each variable appears only once. All fractions are in simplest form, right? So you're not going to ask me anymore, do I need to simplify my fractions? Of course you do. No negative exponents. That is never allowed. And there are no roots of variables, right? Okay, so what are some examples of simplified monomials? So for example, 5x squared, that's a simplified monomial, all right? 2 over 3x is a simplified monomial. Like just, 27, that's a simplified monomial, all right? You could have like 27xy, whatever, all right? But basically like simplified, no negative exponents, yeah.
With eyes, mean that's not simplified because they're roots.
Eyes, no, eyes are okay. All right, but we're not going to have them as coefficients anyway, so like there is nothing. No, that's 27xy, that's my like 7. Okay, a polynomial then is a sum of monomials. So for example, if I have, 3x minus 2y, right? Do you see how you have a monomial, and this is still a sum because it's plus negative 2y, right? And then, so for example, let's say you have 2 over 3x to the 5 plus 4x squared minus 5, right? I don't know, that's a polynomial. Okay, the degree of a monomial is the sum of degrees of each variable. Okay, so for example, if I have 3x to the 5, all right, so look at the variable, it's just an x. The exponent is a 5, so this has a degree of 5. Similarly, if I have, let's say, 2x squared y to the 7, now I've got two variables, and the degree is the sum of the exponents, which is 9. Okay? So that's just if you have a monomial. Both of those are a monomial. Okay, the degree of a polynomial is the degree of the monomial with the greatest degree. Okay, so basically the highest degree of of all of the monomials. So for example, if I have 4x cubed plus 7x to the 6, what's the degree?
6.
Degree of 6, correct. If I have x squared y cubed plus 2x squared y, okay, this monomial has a degree of 5. This monomial has a degree of 3. Together, the higher number is 5, so this has a degree of 5. Okay? Before I take your question, notice the highest or the degree, it's not always the first exponent, right? So just watch out for that. Okay. Yeah.
How is 2x squared and y squared, how is that degree of 9?
It's 2x squared y to the 7. I crossed my 7s. Okay. All right, here. State whether each expression is a polynomial. If it's a polynomial, state the degree. Okay. We've talked about polynomials before. Polynomials basically have exponents that are integers of 0 or higher, right? So basically they're whole numbers. So if you have x to the 0, x to the 1, x to the 2, x to the 3, that's a polynomial. So here, you see how there is a y in the denominator? That means this is not a polynomial. Okay? Right, because if there's a variable there, then it's y to the negative 1 technically, right? So that's not a polynomial. Okay, here, this is a polynomial. You see how all of the variables have exponents that are integers, right? 0, 1, 2, 3. So that is a polynomial. And then let's see what the degree is. What's the degree for the first term? 6. What's the degree for the second term?
7.
And here?
2.
2, right? So the degree here is 7. Okay. All right. This is a review of Algebra 1, right? Product of powers. So just to remind you, if you have two powers, right? If you have the same base, different exponents, and you're multiplying them, you add the exponents. If you're dividing them, you subtract the exponents. And then do you remember a negative exponents brings something to the denominator, or if it's in the denominator, it brings it to the numerator? Power of a power, if you have x to the power of a to the power of b, you multiply the exponents. Power of a product, if you have something like this, you kind of like distribute the exponent. Same with the quotient. And then 0 power, anything to the power of 0 is 1. Okay? All right, so let's simplify some expressions, and we're going to use all of them. Okay, if you have an expression that you need to simplify, that means they have to be without parentheses, no common terms to add or subtract or combine, no negative exponents. I can't stress that enough, okay? No negative exponents. All right, let's do this. So here, you have a negative exponent. A negative exponent basically takes the reciprocal, right? So this would be 2/3 to the power of 2. And then who does that 2 belong to? Who does that square of the square belong to? Both of them, right? So this is just like doing 2 squared over 3 squared, which is 4/9. Okay? Now I understand you might be able to go from here to here directly. Okay? If it's absolutely like important that you show work, like if I've stated you must show work, at least show me this first step, and then you can go from here to this last step. Okay? All right. Here, same base, different exponents. You're dividing them. What do you do to the exponents? Subtract them, yeah.
Why do you switch it to 2/3?
Because the exponent here is a negative exponent. Negative exponent means take the reciprocal. Okay? All right, so here, this is going to be n to the power of 2 minus 10. No, always upper minus lower. Okay? Numerator minus denominator. So this is n to the negative 8, but you can't leave it like that. So it's going to be 1 over n to the 8. Okay? All right, this one, blah, 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 to the power of 0. Anything to the power of 0 is just 1. That's it. Okay? All right. So here they are. Okay, so you can do this one in like such a variety of ways, right? I'm going to just combine terms first. So here's what we're going to do. First, combine the coefficients. 2 times 3 is 6. And then combine the exponents for each variable. So you have a, and then you have an exponent of negative 2, and then 3. We're going to add them because the a's are being multiplied. Times, you have a b squared that only shows up once. C to the negative 2. Okay, let's just simplify, and then we'll move things up and down. So here I got 6, a to the 1. I don't write the 1 exponent, b squared. And then here I have c to the negative 2. So what happens to that? It goes on the bottom as a denominator, c squared. And that's your final answer. So do you see that? Each variable only shows up once. There are no negative exponents. There are no parentheses. Okay? All right. This one. Who does that 3 belong to? Everybody. So here's what you're going to do. -2 cubed, -8. A to the 4 cubed will be what? A to the 12 over B to the 6. It's, yep. Okay, good. Okay, so here we are just subtracting, right? So this is going to be -x squared minus 3x plus 4. Okay, please do me a favor. Take a step and just distribute the negative, right? -x squared, -2x, positive 5. Because if you're doing it in your head, you'll do it for the x squares, you'll do it for the -2x, and then by the time you get to the 5, you forget that you had to distribute that negative, and then you'll mess up, right? Okay, so here we combine like terms. What are we going to get? Uh-huh. Uh-huh. Correct. Okay. Okay, this, I mean, again, this is like so algebra 1, right? You distribute, what are we going to get here? 6x cubed. Awesome. Okay. So here, distribute. Okay? All right. 4/3 times 6. What is that going to be? 8. X to the 4. Plus 4/3 times 9. So the 3's cancel. You have 3 times 4, 12. X cubed. Minus how much? 16x squared. Everybody agree? Okay. All right. Okay. Distribute. So let's see. A to the -3 times b squared. So here we're going to have -3. So I'm going to write them in like alphabetical order. A's first, then b's, right? So a to the power of what? When I distribute? 0. And then b to the power of 3, right? So because we're multiplying, we're going to add the exponents. -3 plus 3, 0. 2 plus 1, 3. And then that'll just, yeah, it'll just be a 1. So plus 4. Okay, a to the -3 plus 2 is -1. B to the 2 plus minus 1 is 1. Okay? Minus 5. A to the what? And B to the 0. Okay. Now, when it comes time for you to simplify, all the zeros of it, all the exponents of 0 will turn that variable into a 1. And then when it comes to the negatives, you really have to make sure to only move the thing that the negative exponent belongs to, right? So here it's going to be -3b cubed because a to the 0 is just 1. Plus, okay, there is a negative exponent here. Who does that -1 belong to? The a. So just the a moves down. The 4 and the b stay where they are. So it'll be 4b over a. Okay? Minus 5 stays where it is over a squared. So many times, like when I'm grading something like this, that last term, somebody will write it as -1 over 5a squared because they'll just, bring this whole thing down, right? And then I have to take off like so many points for it, right? Because that's a big thing. So be careful. Always ask yourself, who does the negative exponent belong to? That's what moves. Okay, so this one. So basically what we're going to do is we're going to distribute this x to each of these, okay? And then the -4 to each of them. So this is going to be x cubed plus 4x squared plus 16x. And then what? Right now, the -4 gets distributed to each of them. So -4x squared minus 16x minus 64. Is that okay? Does that make sense to you guys?
Yeah.
Yeah? Yeah? Makes sense? Okay. So this is going to be x cubed. The 4x squares go away. And minus 64. Okay? Okay, how would you do this next one? Right. When you've got three binomials to multiply with each other, first do do two of them. And so in order to decide which two to do first, if there's a pattern like this, please do that first. So what's a plus b, a minus b? Very quickly. A squared minus b squared. That's how quick it's got to be, right? And then distribute it to the other one. Oh, what happened here? To this. Okay, so I'll give you guys like a minute to go ahead and do this. What is it? Okay. Is that right? Okay. 3a squared b minus 2ab squared plus 3b cubed. Yeah. So this is actually like good enough. This is actually like, it's like standard form for expanding this. Yeah.
Why isn't 3a squared? Why isn't that 3a squared b?
Here, this one. So we got this because we multiplied this times this, and it was 3a squared b. And then we did these two, right, the inner ones, 2ab squared. Yeah, it's a lot of a's and b's. Okay, this one, I love these ones. So first I like to go inside and do the insides, right? So here, this is to the power of 3, okay? Yep. Okay. All right, so let's see what we have here. We have the 2 and the 3. All right, so look at the x's. I have x to the power of 6, right? And then what about the y's? I have y to the negative 3 minus 5, which is y to the negative 8, but I can just write it on the bottom as y to the positive 8. Okay? Which one? Okay, wouldn't it be a negative what? Okay, so let's take a look at the x's. I have x 2 on top, negative 4 on the bottom. It's always the top one minus the lower one. So 2 minus negative 4 is 2 plus 4, which is 6, right? And then here, negative 3 minus 5 is negative 8. Okay? Is that okay? So now, what would we do? Now we have a negative exponent there. So first take a reciprocal, 3y to the 8, over 2x to the 6 to the power of 3. Okay? And now distribute. So it's 27, y to the 24, over 8, x to the 18. I don't think there was anything new here from Algebra 1, right? I think this was all from Algebra 1, right? Yep. Okay. So this one here, you have a binomial cubed. We haven't learned yet the rule to do this, which we will in this lesson, in this chapter, but first, you're just gonna multiply this by itself 3 times. Okay. Now, the first one though, please use the shortcut, right? So we're gonna square the first term, 4d squared. We're gonna square the last term, plus 9, okay? The middle is gonna be 2 times negative 3 times 2d, right? Because this is 2d minus 3 squared, right? This is 2d minus 3 squared. So we square the first term, we square the last term, and the inside term is going to be this times this, negative 6, times 2, negative 12d. Okay, and then I got 2d minus 3. Okay, so let's see. So first let's multiply 2d, this 2d, by everything here. So that's going to be 8d cubed minus 24d squared plus 18d. And then I'm going to multiply this negative 3 to everything here, which is what? Negative, what would that be? Negative 12 d squared plus 36d minus 27. Okay, so that's 8d cubed minus 36d squared plus, how much is that? 54? D minus 27. Okay? All right. So it's a lot of work. You just have to be like super careful. But there isn't really anything new here from Algebra 1. There shouldn't be. Okay? All right. That's where we'll stop today.